Introduction: a new conceptualization of the spectrum and prevalence of mast cell disease. Nearly 150 years ago, German pathologist Friedrich von Recklinghausen was the first to describe mast cells, reporting in 1863 the observation of these granular cells in frog mesenteries. In 1875, German anatomist Wilhelm Waldeyer reported finding mast cells in a tissue spread of rat dura mater, and named these cells embryonal or plasma cells. 2 years later, Waldeyer's medical student Paul Ehrlich described in his dissertation the discovery of human connective tissue of these same cells, which he termed Mastzellen, or well-nourished cells, due to their rich granular content evident from unique metachromatic staining properties with aniline-positive dyes. This work contributed to Ehrlich being awarded the 1908 Nobel Prize in Medicine. Meanwhile, from the clinical perspective, English dermatologist Edward Nettleship and English ophthalmologist Warren Tay described in the British Medical Journal in 1869 a rare urticarial skin disease, a symmetric distribution of pigmented maculopapular lesions. A decade later, this disease was termed urticaria pigmentosa by another London dermatologist, Alfred Sangster, and another decade later, German dermatologist Paul Gerson-Unna was the first to associate mast cells with human disease, noting the presence of these cells in the lesions of urticaria pigmentosa. Yet a further 6 decades passed before, in 1949, Oakland, California County Hospital pathologist John M. Ellis first associated mast cells with internal disease in an autopsy, finding multi-organ involvement in a 1-year-old child who died of cachexia, thereby initially defining systemic mastocytosis. This breakthrough was followed in 1957 with the first report by Israeli hematologists Pinhas Efrati, Abraham Klajman, and H. Spitz of a clear case of the most aggressive form of systemic mastocytosis, mast cell leukemia. Identification of mast cell products began in 1937 with the discovery by Swedish workers J. Erik Jorps, Hjalmar Holmgren, and Olaf Wilander that the metachomasia of mast cell granules is due to heparin. This work was followed in 1953 by the findings in mast cells of unprecedented histamine content by Scottish radiotherapist James F. Riley. Through the remainder of the 20th century, there continued to evolve the modern understanding of not only the hematopoietic origin of the normally widely, sparsely distributed mast cell, but also its fundamental function, namely, to produce and release a wide range of molecular signals, generally termed mast cell mediators, which contribute to the homeostasis of all cells, organs, tissues, and systems in the body. In 1987, Vanderbilt allergist immunologist Lawrence Schwartz and colleagues defined tryptase as a highly sensitive and specific marker for mast cell activation in mastocytosis. In time, the enormous complexity of the biology of tryptase and its many isoforms would become more apparent. And it also would become more apparent that serum tryptase levels reflect the total body load of mast cells far more than their activation state. Molecular genetic insights began emerging in 1993 with Furitsu et al.'s identification of the D816V activating mutation of the KIT transmembrane tyrosine kinase receptor CD117. This mutation later was proved to be present in most adult systemic mastocytosis. Moreover, in 1998, Spanish hematologists Luis Escribano and Alberto Orfao and their team showed that the mast cells, in many cases of systemic mastocytosis, unlike any known normal cells, co-express the aberrant doublet CD117CD25, or CD117CD2, or sometimes even the aberrant triplet, CD117CD25CD2. In 1994, insights began emerging that the accumulation of mast cells in mastocytosis may be due more to KIT's effect on anti-apoptosis than frank proliferation. And in the last decade, this dominance of anti-apoptosis, through other factors too, has been clarified by Gunnar Nilsson's team at the Karolinska Institute and others. For nearly a century after Unna's first association of mast cells with a pathological state, mast cell disease, cutaneous or systemic, was thought to be a disorder of mast cell proliferation, with further consequences from aberrant mediator release. In 1991, though, their clinical observations led pharmacologists John Oates and Jack Roberts of Vanderbilt University to hypothesize the existence of a spectrum of disorders of mast cell mediator release, i.e. mast cell activation, with little to no proliferation. Evidence of such mast cell activation disease continued to accrue, and the year 2007 saw the first descriptions in the literature of monoclonal mast cell activation syndrome, shortly followed by the first formal proposal for diagnostic criteria. In 2007, coincidentally at the University of Bonn, where Friedrich von Recklinghausen had begun his medical schooling 155 years earlier, critical insights into the causes of the marked clinical heterogeneity of relatively non-proliferative mast cell activation disease were provided by German pharmacologist/geneticist Gerhard Molderings and colleagues. Their finding of a large array of mutations in the mRNA for mast cell KIT, the mast cell's principal regulatory element, and a cohort of mast cell activation syndrome patients, was extended further in a follow-on paper in 2010. Given that the range of KIT mutations, for which commercial testing is available, is still very limited, these findings raise the question of whether non-monoclonal mast cell activation syndrome, aka primary idiopathic mast cell activation syndrome, might be more accurately termed mast cell activation syndrome of undetermined clonality. Once whole KIT sequencing becomes commercially available, it will be an early order of research business to determine whether the findings by Molderings et al. Apply to the general mast cell activation syndrome population. In 2007, Valent et al. Reported the curious affair of two patients who suffered severe hypotension following bee or wasp stings, but who had normal tryptase levels and no cutaneous or marrow mastocytosis. However, one patient had one of the minor clonal criteria for systemic mastocytosis, and the other had two of the minor clonal criteria. They proposed defining such patients as having a monoclonal mast cell activation syndrome. At the end of 2010, mast cell researchers Sam Aiken at Harvard, Peter Valent in Vienna, and Dean Metcalf of the U.S. National Institutes of Health published an updated proposal for diagnostic criteria for mast cell activation syndrome. Aiken et al. Proposed a fundamentally new conceptualization that all mast cell disease first and foremost manifests aberrant mast cell activation, thus engendering a new top-level designation of mast cell activation disease to describe the full range of pathologic mast cell states. The proliferative and rare diseases of cutaneous and systemic mastocytosis would comprise one element of mast cell activation disease, while the increasingly apparently quite prevalent various forms of the relatively non-proliferative mast cell activation syndrome would comprise the other principal element of mast cell activation disease. Aiken et al. Further ventured that a diagnosis of mast cell activation syndrome would be permitted if the patient demonstrated repeated episodes consistent with aberrant mast cell mediator release, laboratory evidence of such release, absence of any other diseases better fitting the entirety of the clinical picture, and demonstration of at least partial response to therapy targeted at mast cells or mast cell mediators. However, It almost immediately became evident that the mutational heterogeneity of mast cell activation syndrome leads to heterogeneity of not only clinical presentation but also therapeutic responsiveness, rendering the criterion for therapeutic response somewhat impractical. Wayland et al. Released an updated proposal for diagnostic criteria for mast cell activation syndrome only a year later, in which the requirement for therapeutic response was relaxed, i.e., desirable but not necessary. Given the paucity of highly sensitive and specific markers for mast cell disease and the challenges in finding aberrant expression of even those few markers, Wayland et al. Also proposed a new way to interpret the serum tryptase level. The serum tryptase level, long a staple in diagnosing systemic mastocytosis, is virtually always elevated little to none in mast cell activation syndrome, likely due to the relative dearth of mast cell proliferation in mast cell activation syndrome. Wayland et al. Thus proposed serum tryptase would now be a marker for mast cell activation syndrome if it rose during a symptomatic attack by at least 20% over the baseline value, plus an additional 2 micrograms per milliliter. However, it was acknowledged in this proposal that this formula was empiric, that only 80% of the authors had agreed with this element of the proposal, and that validation would be necessary, and which at the time of this writing remains unavailable. Thus, after roughly 1.5 centuries of learning and teaching successive generations of physicians that mast cell disease is a rare proliferative process called mastocytosis, in merely the last 5 years it has become readily apparent that systemic mastocytosis is but the tip of the proverbial iceberg of mast cell disease, with the far more common, relatively non-proliferative mast cell activation syndrome comprising the large bulk of the iceberg, largely unseen and unmechanized, for many reasons to be reviewed below. Much research in mast cell biology and disease remains to be done, a challenge at least equaled by the now apparent need to educate the medical community regarding this new conceptualization of mast cell disease.